This is an art attack. This is an art attack. This is Art Attack.
Hello there. When I was a kid, there was this program called Art Attack, and it was hosted by this guy called Neil Buchanan. The basic format worked like this. He would give a little intro, and then he would demonstrate making a small art object using everyday household materials. He'd talk you through the process as well as show you a few variations so you could see different ways you could take the project and make it your own. And then he'd finish with,
Try it yourself, a wide-mouthed frog brush or pen holder.
the one that sticks with me to this day is the one where he shows how to draw shadows on a picture by thinking about where the light can't get to. It makes you want to draw something, see how it works, and try it yourself. Sometimes he'd flex his artistic muscles too, like this one where he looks at some paintings some children did and then uses a piece of cardboard to draw a really impressive, at least to me as a child, ship. He says the technique
reminds me of the technique of the old masters many years ago, the way they used to paint with palette knives, and they used to just smear their paint literally thickly across their paper using a knife.
And I think once every episode he would do these big art attacks where he'd take something everyday and mundane and do something like improbably huge with it. Something you'd never actually do but would get you to think about the potential of the things that you had lying around. It gave you a sense of possibility, like, okay, I would get in trouble if I tried that, but just imagine. Neil Buchanan was and is an artist, but in Art Attack he's an educator. I'm a software engineer, but with Odes in these videos, I'm an educator. One way of framing my goal with Odes and with this channel is to create a kind of art attack for technology and of course for adults, a kind of tech Bob Ross. I want to do this for every part of the software field, from low level to graphics to programming languages to the history of computers, really everything. Even, maybe, when the hype has died down, artificial intelligence. Something that you're going to enjoy watching, and then when I say try it yourself, you might think, okay, that doesn't look so hard, I'm sure I could give that a go, and then try it out and then maybe take that somewhere. And for those of you who follow along, I hope that this can become the seed of something more powerful and serious, a kind of skill that can help propel you through life. In fact, I was just learning today when I was researching how to pronounce Linux that Linus has a book and it's titled For the Fun of It or something like that, which is pretty similar to what we're trying to do here. This video is about the best of the comments on the videos so far, and so I've started by answering one of the bigger questions I've got, as well as a question I'm always working on myself. Where is this channel going? Along the way, I'll also be covering some of the more interesting and occasionally embarrassing mistakes that I've made in the videos. Not because I'm proud of making mistakes, I'm not of the mindset of often novice educators where they feel that mistakes are a kind of badge of honor that show that I too, the incredible K, can make mistakes. I don't think that. I think mistakes are just bad and you should try to avoid them, but they are an unfortunate fact of life and they're worth correcting when you find them. So we'll be covering some of those as well, and hopefully I will be able to get through it without being too embarrassed. Plus, sometimes they do let us explore interesting additional topics related to the thing I made a mistake about. The main question I got in the Introducing Odes video was, what is this debugger and how do you use it and what is in that mysterious profile file? The debugger is Redare2. I like it, it looks cool, it feels powerful, but it takes a little bit of energy to learn how to use. I'd probably categorize it as an expert interface. Nice when you know it, frustrating when you don't, but we're software engineers, right? So we can learn this stuff. Anyway, here's a quick step-by-step to getting somewhere useful with it. Here we've got a basic C project with a main.c which I've compiled into a main executable. It prints hello world to stand it out and exits with Hexacode 77, and we're going to use Redare2 to step through it to see how it works. Note that while you can get Redare2 to work on a Mac, it's not particularly convenient, so this is running on a Linux EC2 instance. Redare2 sort of hides standard out, so if we want to view standard out alongside Redare2, we need to create a special profile which will tell Redare2 to send the output of the executable to another terminal. We use the command tty to get the device corresponding to the other terminal and then create a profile file that looks like this. We then put a long sleep in the other terminal and clear it using Command K to get an empty terminal. Then we run redair2 with the D flag to debug an executable, and then pass in the profile 2 using this -e dbg.profile option. From here on, I'm going to zoom out the terminal a bit. I know it's not so good for those of you on small screens or far away from large screens, but redair2 is a pretty information-dense interface, so it's hard to avoid while properly showing you how the tool works. redair2 opens up with a prompt, and we can use the question mark command to explore it. A single question mark gives us an index of all the commands, and then we can put a question mark on other commands to learn more about them. For example, AA question mark will show us some analysis commands. We're going to use AAA to analyze everything in the executable and load it into redair2. We do this so that we can get all of the function names and comments and annotations and stuff like that. To learn a bit about debugging, we can run db question mark to look at those commands. We can see that we can run db sim.main to insert a debugging breakpoint at the start of the main function. We do this and then run dc to kick off execution. DC standing for debug continue. After this, we can run V to enter visual mode. Assuming our terminal is large enough, we now have 3 panels. The disassembly of our main function on the left, the stack data in the top right, and the registers in the bottom left. We can use the up and down keys and the left and right keys to scroll around if we want to. This visual mode exposes some keyboard shortcuts, so we can now hit S to step through the program, watching the registers and the stack change too. Now that we've gotten to just before we call printf, I can show you that if a register contains an address, for example RDI, which contains the address to the string we're going to print, then we can click that register with our mouse and go to that part of memory. We can then click RIP, recall that the IP in RIP stands for instruction pointer, to go back to what we were about to execute. We can also hit the colon key and then run smain to seek back to the top of the main function. When you get to a function call, you might want to step into it and see its instructions, or you might want to step over it and just get to the instruction after that function returns. If you want to step into it, you just press the S key like normal, but if you want to step over it, you press Shift S, or I guess uppercase S. If you accidentally hit lowercase s and you end up inside that function and you want to get out, you can hit the colon key and then run DSF for debug step until frame exit. We can now see that our message gets printed out. If we want to continue execution until the end, we can hit the colon and then run DC for debug continue. Those are the basics to get you started. I definitely recommend using the question mark a lot to learn about all the different things it can do, and actually ChatGPT is pretty good at telling you how to do things in redair2 as well. In the binary coding video, I often got the question about how I created this kind of C REPL thing where I'd edit the code and then the results would show up on the right. I actually invented this approach when I started my Advent of Code No Screw Ups project, which most of the old videos on this channel are related to. My challenge to myself is always to come up with a good enough plan that each part only takes me 30 minutes from first line of code to correct answer. I realized after a few days that it's useful to have a process constantly running the code and showing me the errors and output. This keeps me in a tight feedback loop with my code and goes some way towards replicating in a different setting the interactive feeling of working with a good test suite. Our basic version is pretty easy to do. You can use the tool watch, which will repeatedly run a command and then show you the output. I like to speed it up a bit and enable the color display. I think most Linux distributions come with watch, but Mac doesn't, so you might need to install it with brew or similar. You can also just use a shell loop if you like. See, if I was Brett Victor, I'd have to write several long essays and invent a whole new computational paradigm to get this kind of interface. That's a joke, Brett. We love you. Thanks for all the essays. Please don't turn my house into a giant computer. Okay, thanks. As for the C video, there were 2 kind of embarrassing errors in this one. The first is that in the data types I listed out, I got the max sizes for the char types wrong, and bizarrely at the smallest and most obvious sizes. These are easy to calculate. Since we know that an unsigned char is represented by 8 bits, we can see what 8 ones equals, 255. Then if we want to work out the signed equivalent, we knock out the first bit because that's going to be used to determine the sign, and then work out what that equals, 127. So it can range from minus 127 to plus 127. Why I thought any system would range from minus 127 to plus 128 is a complete mystery to me. Thanks to Honor Olcher for pointing this one out. Another mistake I made was in the memory diagrams. I created diagrams like this which give each character an address visually. But that's not right. Typically, all modern computers give each byte an address, and then when we represent that in hex, it's actually 2 characters from 00 through to FF. So it should look like this. A half byte, which is a single hex character, is usually called a nibble. So in my mind, I just invented a machine which does nibble addressing. And I believe if you transported that video into a universe where computers use nibble addressing, then all of that part would still be correct. But in this universe, that's pretty odd. I am starting to watch these many more times before I post them, so I should be catching more of this stuff. Now we come to the Making Bitmaps video. Now recall what I said in the C video about one of the challenges with manual memory management being that you have to be very careful to remember to free memory and to do it properly. Well, it didn't take me very long to make a mistake. In the bitmaps video, I wrote this function freeBitmap, whose job is to free the memory allocated to the large pixel array, which it does successfully. I realized when writing it that it wouldn't be very good to have a reference to that freed memory hanging around, so I decided to set the bitmap pixels field to null so it couldn't be used. My mistake was assuming that C structs behave broadly like dictionaries, hashes, or objects in higher level languages, in that you can edit a property on them and this will be reflected wherever else in the program the struct is referenced, for example in the calling function. So I was hoping when I set it to null here, it would be set to null everywhere. And that is not true. In C, structs are passed by value, similar to how numbers are. So when we set the pixels field to null, then we're setting it only for the copy of the struct inside this function, essentially completely useless. If you're coming from a higher level language, it might be better to imagine a struct not as a kind of record or dictionary type object, but instead as a kind of named tuple. Or tuple if you prefer. Anyway, if we want to make this work, we'll need freeBitmap to take a pointer and use the arrow operator instead of the dot operator. This accesses the field of a pointer to a struct instead of a direct reference to a struct. So thanks to GameDevLife9950 and DingBackCrazy for pointing this one out. Salim444 made an interesting comment about Little Endian being more intuitive if you write memory addresses from the right to the left, which I thought was pretty interesting. I'm actually curious to know if anyone else resonates with this, particularly if you speak a language which is written from right to left. A couple more silly mistakes in the assembly video. The first is that for some reason I just totally missed out the register X11 on my ARM64 assembly diagram. The second was that I got one of the system call numbers in the diagram wrong. The exit system call here should be code 1, not code 4. Another more interesting clarification is my use of the instructions JA and JB in this example. I realized that something was odd when I noticed that x86 has a few different conditional jumps that in my mind should have been the same. For example, JA for jump if above and JG for jump if greater, which in theory should be the same thing. The difference is that JA and JB, jump if above and jump if below, are used for unsigned integers, whereas JG and JL are used for signed integers. The practical difference is they check different flags. For example, JA checks the carry and 0 flags, whereas JG checks the 0, sign, and overflow flags. It doesn't affect this example, but I think some of the explanation I give in this video doesn't fully account for what's going on here with signed and unsigned integer comparisons. I also thought I'd share this comment for the lovers of coding games amongst you. I've not actually played any myself because I'm a bit worried about falling into another mind hole like I did with Factorio, but if you have the time and concentration, you might have some fun with these. The Fast and Beautiful assembly video was a big pronunciation video for me. It is not simmed, it's simd, as many of you pointed out. I could have looked that up really, but as I write this script, I still haven't actually worked out why I say Linux. When I was young, I said Linux, and I think when I was at school, I ended up in some disagreement about which one was the right one, and we ended up concluding that some people say Linux and some people say Linux, so I stuck with Linux because I guess that's what I said. But then I ended up switching from Linux to Linux sometime over the years, and I have no idea why. Maybe some people around me were saying Linux and I just mirrored them. Maybe they were my boss or something like that. Anyway, time to find out.
Linus or Linus? What's your preferred pronunciation?
When I speak Swedish, it's Linus. When I speak Finnish, it's Linus. When I speak English, it's Linus. And I really don't care how people pronounce my name. But Linux is always Linux.
Okay, well, Linus says it's Linux, so I guess I can probably go with him on that. Another comment that many people left is that the file here actually does have one line because POSIX, which is a set of standards for operating systems, defines a line as a sequence of characters terminated by a new line character. What you've got there is a file which has one line plus some extra characters on the end. This is pretty useful knowledge, but it does also make me laugh when I see a file with one line having 0 lines and stuff like that. There were some other good comments on this one. I particularly like this one from Tree Librarian, which explained a few reasons why XORing a register against itself was preferred to moving a 0 into it, aside from just being smaller in bytes. It also doesn't require the processor to read and process the immediate 0, and it's useful for optimization too. It's worth pausing and reading this comment if you're curious. Tree Librarian was also kind enough to contribute an alternative assembly word counter which was better to their taste. Now, I believe this version has the advantage of eliminating branching in the main loop. This is often desired when writing high-performance assembly because long stretches of branchless assembly allow the processor to find ways to execute the instructions in parallel rather than in series. Conditional branches, since they can go one way or the other, limit the processor's ability to predict which instructions will be executed in the future and so limit that optimization. I'm simplifying a lot here because this isn't a video for me to talk about instruction pipelining, but we'll get there at some point. Tree Librarian also included an implementation using another SIMD architecture, and I put both in a link in the description. In the stack video, there was a great comment from Programming Rainbow which talks about three things. The first is that Turing is often given a lot of undue credit, and I agree. I always feel a bit embarrassed when people take the contributions of people from minority groups, in Turing's case as a gay man, and distort them to fit a particular narrative. I know why they do this, because the idea is that the people from minority groups are not given enough credit, but I also think it's a little disrespectful to their authentic legacy, their actual work. The truth is often more interesting and more life-affirming than the exaggeration. So in this video, I was pretty keen to stick close to the truth as far as we can evidence it. And I don't think Programming Rainbow is saying I was exaggerating his contribution exactly, but that some other figures were missing. One of those is Alonzo Church, who was Turing's PhD supervisor and co-author on some of his most important work. I won't talk too much about Church now, other than that I do have some plans to talk about him in the future. I have a vague theory that Church's work is one of the key strands of early computing, which we might today categorize into the C, Haskell and Ruby style languages. I think it's definitely fair to say that Church was the originator of much of the key thinking around functions and recursion in mathematics, and a lot of recursion in computing of course relied heavily on that work. One of the reasons I use the term subroutine so much in that video is because the distinction between subroutines and functions is quite critical at that point in history. I believe I read, possibly in Dijkstra's work, language around a function being implemented by a subroutine, which gives me the idea that at least back then, the function is the abstract theoretical object, whereas the subroutine is the concrete machine-level implementation. Programming Rainbow also mentions Tommy Flowers, and again, I haven't researched him enough to say a lot in this video, but he's definitely an interesting and worthwhile character, having proposed, designed, built and even bankrolled some of the critical early computers in Britain in World War II. I seem to recall actually in the development of Turing's Ace computer he spoke about sending the work of building the delay lines, an early form of memory, to a department of the post office, and that is where Flowers worked. So perhaps it was to him. In any case, definitely a good topic for a future video. So thanks for the comment, Programming Rainbow. I think this is a comment which adds quite a lot to the video and I can really appreciate that kind of comment. On the crafting executables video, James Gray pointed out that the R in the RAX register in the x86-64 architecture stands for register, which I have confirmed based on my own research, but it does bug me a little bit because in 32-bit x86 the registers were EAX, where E means extended, but they're registers too, and they also exist in x64 as well. Anyway, I'm sure they weren't thinking of me personally when they named the registers, so I guess I'll have to get over it. Now, as promised, I'm going to answer some questions. What fonts or apps do I use? So at various times throughout this series, I've used these fonts. The Monospace series of fonts from GitHub, which is great and actually technically kind of cool, so definitely recommend that series. There's 5 of them and you can use them for different purposes, as I often do in these videos. I also use Mona Sans, I think that's how you pronounce it. I should just stop saying anything to do with pronunciation. Mona Sans, which is another font from GitHub. There's also a related one called Hubot Sans or something like that, which I've not used. And as for drawing apps, I've mostly used Excalidraw, along with the fonts that come with that, the kind of handwriting-y ones. But for some of the later videos, I use TLDraw instead, which is also cool. I've got a friend who works there, so I felt a kind of loyalty to at least take it for a test drive. And then in the later, kind of more recent videos, I've been just going straight from After Effects. I sometimes get questions related to like book recommendations, and this one actually I think is a more interesting version of the same question. If you were to learn everything related to computer science from scratch again, how would you approach it? Any books, newsletters or resources that stand out? So one of my slightly guilty secrets is that I don't really read technical books that much, or rather I read quite a few technical books, but not very much of any one particular book. So I almost never have any good book recommendations. I wouldn't go so far as to recommend that you don't read books, but I could see myself working myself around to that opinion in a few years. So the jury's still out on whether I think books are generally a good idea or a bad idea. Probably a good idea in some cases, but I sometimes find books they can be a replacement for learning rather than a useful tool for learning. So they give you a bit of satisfaction that makes you feel like you're learning when you can just buy the book and then nothing particular can come of it. So sometimes I feel the impulse to buy a book might be better served by doing a little bit of programming or just a tiny bit of freely available reading on that particular topic. You might get more out of that than just buying the book, which might sort of feel as satisfying. I'm not trying to say you're foolish for buying books. I don't think that's true. But that motivation for a learner is a very scarce resource, and this includes myself, and you should treasure every piece of it that you get. So if you feel like, oh, I'd actually really like to learn more C, the first thing you should do should be to go out and learn whatever part of C you don't know yet, and then probably, if you can persist with that, then maybe go and buy a book and actually read part of it. But in keeping with the actual question, let's say that I today forgot everything I knew about computers and I need to start from scratch. I would find some exercises and I would do them. I would try to code as much as possible, which is the advice I generally give to anyone who wants to get into computer programming or anything similar to that. Find a way to convince yourself to do as much programming as possible. If it's too hard, make it a bit easier so you can do more of it. If it's too easy and you're getting bored, make it a bit harder and then just do more of it. That's generally a good idea in all situations. As for where to find the exercises, I don't think it matters too much as long as you're doing a lot of them, but I think if I was starting again now, I might start with a data-centric introduction to computing because I've got a lot of respect for the educators who put that together. So I always wonder what that would be like for a beginner to go through. But I wouldn't stay there for long. I would use it as a jumping off point to do more coding, essentially. And I would supplement this by reading small amounts of material very deeply. So if I ended up on arrays, for example, I would probably start by reading the Wikipedia page for arrays, top to bottom, really slowly, carefully, and in depth, to try to understand as much as possible, which is actually not too far from how I research today. So for example, let's just look at the first paragraph of the Wikipedia page for arrays, brackets, data structure, or something like that. I'm going to read it out for you, just like I would for a student if I was teaching. In computer science, an array is a data structure consisting of a collection of elements, brackets, values or variables, of the same memory size, each identified by at least one array index or key. An array is stored such that the position of each element can be computed from its index, pronunciation check, tuple, I think. Computed from its index tuple, by a mathematical formula. The simplest type of data structure is a linear array, also called one-dimensional array. I guess that should be a one-dimensional array. Somebody go in and correct that. There's a lot in just that first paragraph. If you can understand just that paragraph in depth, you've got quite a lot of knowledge. The challenge really is to not give up before you've learned it. Most people struggle with that, and that's fine. I don't think it's a moral failing or anything. It's just part of what it's like to be human, that it's hard to work through this stuff. But the better you can get at it, the more you get out of everything you read, and the more you're going to learn. So for example, if you're reading this paragraph, you might have the question, do all elements in an array have to have the same memory size? That doesn't seem right. I've seen arrays with items with different sizes in them, I'm sure, so what's going on there? Now, this would then lead you to figure out the difference perhaps between an array and a linked list, and possibly pointers and stuff like that. So those kind of trails can take you quite far if you really persist in them and you haven't had to buy a book or read a few hundred pages to get that knowledge. Anyway, different people have different preferences when it comes to absorbing this kind of material. That's how I would approach it, essentially with doing a lot of programming and then supplementing this with small amounts of carefully deeply read material related to what I'm working on. I'm just getting into programming. Is Odes for me? Firstly, welcome to the field. It's a great place to be. Odes isn't particularly aimed towards absolute beginners, but you can follow along if you like. You may find some of it interesting. I think I would not hold yourself to understanding all of it. You're probably going to feel bewildered or confused a lot of the time. But if you can handle feeling bewildered and confused, it may still be a good thing to engage with. So you're welcome to do so, and you might pick up some useful things along the way. Do you have a Discord or something similar? I do not. At some point, I would like to add more of a community aspect to what we're doing with Odes, but that sort of thing is tricky to get right and quite time-consuming and horrible if you get it wrong. So right now I'm focused on getting videos out regularly and as regularly as possible. And as I start to nail that, I'll probably start thinking about the way the community part should work and should feel. Until then, keep commenting and engaging with those. And also, if you want to reach me via email, then my email is hello@odes.net. I do sometimes get the time to go through LinkedIn, Instagram, X, and other places, but it's hard to keep on top of all those different inboxes. So if you really want a response, although it might take a bit of time for me to get to it, then email is the best way to reach me. I've also gotten a few comments about my personal and professional journey, so I'll talk a bit about that now. And I'll try and, to some extent, semi-ad-lib it with a script on the back of it. So I learned to code as a teenager. It started when my father showed me a spreadsheet where you could click a button and all the cells would kind of change color, and I thought that was obviously incredible as a 10-year-old. So he then showed me some of the code behind it, and I ended up making these sort of quizzes, like 20 questions things with big nested if-else-if statements and horrible stuff like that. So that was really when I got started into it, and I kept up an interest in there. I worked through some of the Python documentation, which it's really funny reading that now as well. Then I got interested in other technologies like making little websites, and as many teenage boys do, I got interested in what we might charitably call computer security. I still have kind of a mental credit to myself for developing the world's first web-based worm, but that is a difficult title to actually claim, so it's just in my head. My fascination with the Windows netsend command caught the attention one day of the network administrator at my school, and I was once sending a message to my whole class, and I heard this voice from behind me saying, "Very wistful," and then the network administrator walking off down to his office at the end of the room, and I was like, oh no. But I ended up hanging out in the network office kind of odd lunchtimes and breaks and picking up a few things. I would be given certain, some of my indiscretions would be ignored as long as I passed on the security flaws that I found to the network administrators first, which is actually a pretty good deal for a teenage hacker, because it's fun to find the things and then it's not so fun to get in trouble. He later ended up giving me my first job in the school's network department, running cables in the summer and formatting machines and such in the evenings. Despite not being a teacher, he and his colleague were great mentors to me, and I'm very grateful for them for putting up with me as a teenager. However, also, like many teenage girls, I got very interested in online diaries and comments and chatting to people on the internet and that sort of thing. So as part of this, I built a few community websites which got like a decent community buzzing around them for a little while, which was actually great both as a kind of writer and as an engineer, because as an engineer, having users who you feel responsible for providing a good service or product to really changes the way you approach your work. It gives it a sense of weight and importance that it didn't have before. So that was pretty valuable too. I remember spending a summer with like this really ridiculously long list for a rebuild of a website that I was running, that I just worked through. The work ethic I had in those years is unparalleled since, which is quite something given how mediocre my work ethic at school was. When it came to decide on my degree course, I had two options in mind. The first was ethical hacking at Abertay Dundee, and the second was a course called Performance Writing at a small experimental performing arts college in Devon called Dartington. In the end, I decided that I'd find a computing degree kind of boring, and so I went to Dartington and studied writing instead. And I never regretted that decision. It's hard to summarize exactly what you learn in such an experience, but for example, the skill of being able to read dense technical materials slowly and carefully is actually a pretty direct take from a technique that in literature degrees they call close reading, or you might spend a whole hour just analysing one sentence to see what's going on and what's behind it. Experimental arts education also typically comes with a fairly strong strand of autonomy. So if you don't get it together to make a piece of work, then you're just going to fail your degree. Nobody's going to come along and hit you over the head to make this art project, which is probably going to take 12 weeks to do. And then if you want to feel good about your work, you've got to get it together to have a good idea and then see it through to a successful conclusion that you feel satisfied with. And that builds a whole set of skills that I would struggle now to even describe. And then there were some great romances too, the kind of romances you only get at art colleges. And they transform you in their own ways. Plus, performance writing, my degree, it's kind of like code, really. Writing that performs, code that executes. There's a lot of similarity between a lot of the ideas in literature and language and linguistics and in programming, I think. Anyway, it was all very enriching, but it didn't exactly pay the bills after I graduated, so I ended up entering the tech industry through a series of small, slightly quirky companies, and along that journey also learned how to write code that other people might want to read, as opposed to the stuff I've been writing up until then, which I don't even think I wanted to read. And then I got a bit disillusioned about what it felt to be a day-to-day software engineer, and so I thought I'll try to find a job where I can use the technical skills that I have, but that I'll always be thinking about people. And so I ended up joining a boot camp as a coach. And within a year or two, I was running increasingly large parts of that company. I learned a lot about business there and a lot about the business of education, including having 2 Ofsted inspections under my belt, which I would not recommend to anyone without nerves of steel. Genuinely the most incredible professional test of my life. But most importantly, I learned an awful lot about education. Now, I could talk about education for many hours, which I'm not going to do right now, but I see education as the place that I think I might have something to contribute, something like my career mission. And I'd like to try to see if I can say it. But say it in a grand career sense rather than say it right now in this video. And this part isn't in the script, but I think some people think that focus on technology and focus on education are kind of trade-offs. Like if you're focused on education, you're inevitably focusing on the simplest, sort of most rudimentary stuff and on a different set of skills rather than on the tech side. Now, to me, to be a good educator, you have to know your stuff in depth. It's not always possible if you're in a real education setting to do that, but I think you should absolutely be holding yourself to know your topic really, really well and to be able to explain it in a way that is both accurate and clear. The clear part a lot of teachers focus on, but the accurate part I think is equally important. So through education and trying to do it really well, you can also gain a really precise understanding of your topic. So I don't actually think there's a trade-off there at all. I'm a significantly better engineer than I was when I started teaching, and a lot of that is because of the level of rigor that my knowledge has had to be subjected to, working with so many students across so many topics and having so many questions thrown at me all the time. I moved on from that job at the bootcamp after 7 years, partly because it was time for me, but I also think it was time for the bootcamp sector in general to kind of rethink what it was doing and its place in the world. And I don't think I really had the energy to take that in the direction that I think it really needed to be taken. So I moved on. And now I'm doing this. I'm doing it pretty much full time. I have a little bit of consulting work that goes on, but by and large, most of my time and energy is spent on these videos. As to how I've ended up knowing about the things that I talk about, a significant amount of it's, background knowledge and stuff that I've picked up through curiosity and little projects over the years, but there's also a heavy amount of research that goes into each video that takes it from I'm pretty sure I have a good understanding of how that works and could do some stuff with it if necessary to okay, I can talk about this to a few thousand people and hopefully not made too many mistakes. The paradox of education in 2024 is that pretty much everything you might want to know is out there and ready to be learned. If you want to, for example, learn C in depth, you can definitely go out there and find the correct information necessary to do so. The strange part is that relatively few people actually do this. Odes is my attempt to solve that problem, to find worthwhile topics, to research them carefully, to digest them as an educator into a form which is accessible and engaging to watch, and then to try to get as many people as possible to give it a go. Once people start trying things themselves and build up a little bit of skill and momentum, the whole world can open up. They might then actually pick up The Art of Computer Programming and start reading it because they've got some of the keys that helps them unlock a text like that, and they've got some faith in themselves that they can just go and do this stuff if they want to. It's all about realizing human potential, just like a lot of education. And remarkably, I've managed to get through this whole personal story without once mentioning that I'm